Hello guys, this is CodeNCode, and in this lecture we are going to solve this problem. This is taken from div 2 and this is an A problem, so it is a really easy problem. So question is really easy. Question is, given n, find out the last digit of 1378. So if you have watched the previous two videos where I have explained modulo arithmetic, to calculate the last digit all we have to do is take modulo 10. So that is what we are going to do in this lecture. We will be calculating 1378 raised to power n modulo 10. But if you really remember that one of the identity which says if a and b are modulo to if a and b are congruent to each other, then a raised to power k is congruent to b raised to power k, and we see that 1378 is congruent to 8 modulo 10. So instead of calculating 1378 raised to power n, we can calculate 8 raised to power n and modulo 10. That would give us the last digit as well. So just let's jump into the code editor and start. So yeah, in each time we would be given in the input n, we would read the input n. We are calculating base, that is 8 raised to power n modulo 10. So let's define the power function. It would return long ints, but I have already defined hash defined directive for it, because it becomes really long to write long int again and again, because even in the parameter of this function I have to use like 3 times. So a raised to power n modulo p. So we initialize the result with 1, and if you have watched the video from binary exponentiation, we are going to use binary exponentiation to calculate power quickly. So what we do, you remember, if n is odd, that is n modulo 2 is double equal to 1. Even if you don't write double equal to 1, it would be true only if n is odd. So if n is odd, what we do result is equals to result into a, and then we do n minus minus. Remember, just do this, and then else what we do a is equals to a into a, and then n divided equals 2, and finally we return result. But the problem is we have to take it modulo p. So, and in the previous lecture I explained, if we have to calculate a into b, what we can do, if we have to calculate a into b modulo p, we can write it as a modulo p into b, which is actually this one, modulo p, and then we can take whole modulo p. So we don't have to write we don't have to take modulo every time. We can directly use this. The reason is since ref and a are being, let me write it now. The reason is, since a, when you are calculating a, each time you are making you are calculating it modulo p, so it would be smaller than p, which would be in p is like 10, yeah, so it would be smaller than p, so it would not go outside the bounds. So, and same goes for result. Since the result is also being modulo each time with p, so whatever is stored in the result won't go above 10. So result and a both are like up to 10, or since we are taking modulo with 10, so result and a would be below 10 each time, so their multiplication won't go beyond integer limit. So we, instead of each time calculating this, remember in the previous lecture I explained why we do this. We do this to stop overflow, and since in this case there won't be any overflow, so I'm just taking their multiplication and finally taking their modulo. So this is how we calculate power in modular arithmetic. All you have to do, wherever there is a multiplication operation, just apply the multiplication operator, and also apply modulo after that. Same goes here. Now after that, our result contains the result, that is the last digit. So if you run this for the first test case, when n is equals to 1, of course the last digit would be 8, and if n is equals to 2, last digit would be 4. So you see, n is equals to 2, the last digit is 4. So if we submit this, yep, just submit this. Is it running? And is accepted. So we see how we calculated the last digit of a number. See, we calculated 8 raised to power n because 8 is congruent to 1378 modulo 10. You can also write 1378 completely and it would still give the same result, because in the congruences we have seen that, yeah, same result. So in the congruences we had seen that if a and b are congruent to each other, then a raised to power k is congruent to b raised to power k. So either you can calculate 1378 raised to power n modulo 10 or simply 8 raised to power n modulo 10, both would work. So this was how we applied modular arithmetic to solve some problem. And now in the next video we are going to solve a better problem taken from CodeChef. So till the meantime, thank you guys for watching, and keep coding. Thank you.